So when I start talking about design of experiments, or DOE in short, I usually start by asking the people, how do you conduct your DOE? And the way you conduct the DOE is, you first design your experiment. So what you want to do first is, you want to specify the level of factors that you want to investigate in. You need to set the amount of levels. And then last but not least, find an ideal experiment. And in Molex 3D, you can choose from different orthogonal arrays, or Taguchi arrays as they are called within the software. The next step would be, and probably the most important step also, would be to specify your quality factor. So the quality criterion you're interested in, the one you want to optimize. For injection molding, it's often warpage, but it could also be cycle time reduction and so on. And in order to optimize it or to specify it, what you also need to decide on are the control factors. So the input parameters that go into your experiment. For example, the melt temperature or the filling time. And you can choose several here, don't worry too much about it, as the number of factors does not affect the amount of runs of your experiment too much. The levels are more important here. So once you set everything up and you decided for an experiment, the next step would be to run the experiment. And you either do that on your machine or virtually in Molex 3D. Either ways, once the experiment has been conducted and the data from it has been collected, the next step would be to analyze and to fit the data. So what you want to do is you want to start looking at the results. And Molex 3D, for example, provides a result that is called quality response. And as the name says, what it does is, it will give you information on the response of the quality criteria depending on the level of your factor. So in this example that we can see right here, we have the filling time, the melt temperature and the mold temperature. And what we can easily see is that the curve for the melt temperature is not only the steepest, but it also features the widest range of filling pressure, which in this case is our quality factor. So in other words, or what that means is that melt temperature in this scenario has the highest impact on our filling pressure. So knowing this and knowing the response for the other control factors as well, we're next able to come up with a model and verify our model. And we usually do this with a surface plot, and this is why you do the DOE.